Alright guys, this is 5.1a, Notes on Quadratic Functions, and essentially all we're doing really today is talking about reflection points. First of all, I'm going to go kind of fast through this because I think some of the last few have been pretty long, but the graph of a quadratic function is called a parabola. Okay, a parabola, hopefully you remember that, is a U-shaped graph, a U-shaped. For instance, it could look something like this, it could look something like this, or it could go through the axis. It's anywhere on this graph. It's a U. It's upside down or right side up. Okay. The vertex itself is right here. The vertex is either a maximum, which obviously means the highest point, so that would be like that one there, or a minimum, which is obviously the lowest point, which would happen here. This, of course, is not going to have a minimum because it keeps going and going and going. The arrows tell you that. Same thing with this one. It doesn't have a maximum because the arrows keep going and going and going till infinity, really. Now, again here, it's kind of the same thing. This is my maximum. This would be a minimum. Okay. Now, the axis of symmetry is the line that goes right through that. Literally, it is the line that reflects one side of the parabola to the other through the vertex. And underline through the vertex because that's kind of significant. Okay? This is always in the form of x equals a number, okay, which we have come to find out through our graphing sections is a vertical line. It always, always, always is a vertical line with the equation of x equals whatever the x coordinate of the vertex is. So for instance, in this line, this equation of this line right here could probably be x equals 5. Okay? Just to give you kind of a rough idea. Next page. So when looking at these graphs, and this is pretty easy stuff, guys, because the vertex is just the highest or lowest point. So the vertex here, when you look at it, make sure I got you on camera right here. The vertex here is just, well, this point right here. What is the vertices of that? -2, +4. -2, 4, and of course that is our maximum. We're going to write that in there too. The axis of symmetry, again, is just the x value, but it's x equals -2. Now for instance, it is this line right here, which is x equals, again, -2. Now to find these points, if point P is 0, -4, which is right here, 0, -4, well, P, this little symbol means prime, P prime, hopefully you remember that maybe from geometry, is its reflective point. All the prime points are reflective points. So P prime is right here, which of course is just -4, -4. Same thing with Q. If Q is -3, 2, which is right here, then Q prime is its reflection through the axis of symmetry, which is -1, 2. The y-intercept, hopefully you remember, is just where it crosses the y-axis. This is always 0, comma something, and in this case, well, look at what it is. It's 0, -4. Happens to coincide with the problem we had earlier. Now, increasing and decreasing. Think of what it means to increase, what it means to decrease. Increase on a graph means it's going up. Okay? Decrease on a graph means it's going down. We're going to talk more about that tomorrow, but for now, just realize that it's increasing as it goes up, it's decreasing as it goes down. So where is this graph going up? Well, it's going up. We always read a graph left to right because that's how we read everything. When we go increasing, it's going uphill until this point. Now, it doesn't include that point. That's the top of the hill. Okay? So it's for all my x values that are less than, simply less than, -2. Now notice again, the axis of symmetry, the vertex, x value, all of those are involved with this. And when it's decreasing is when it's going down from there. So x is greater than -2. Now I know that the less than or greater than thing may be confusing, but everything to the right is greater, everything to the left is less. Same thing on this one. Okay, I'm going to go just to the decreasing and increasing. Well, actually, you know what? Let's just do it all. The vertex again is 1, -5. And that is a minimum because it's the bottom, there's nothing below it. Axis of symmetry is always x equals the x value of the vertex. If p is 0, 2, or 0, negative 2, excuse me, then p prime is right there, which is at 2, negative 2. Notice in both of these problems that the y value is the same, the y value is the same, the y value is the same. Well, it makes sense because it's not going up or down any, it's just reflecting across that line. The y-intercept, of course, is 0, negative 2, it's already there. It is increasing, it's going uphill from here to there, it's going downhill from there to there, so it is increasing greater than negative 2, or excuse me, than positive 2. And it is then positive 1. Let me try that again. It is increasing from 1 on, and it is decreasing up to 1. And the last problem here, the vertex again is right here. That is at 4, 0. Axis of symmetry then again is just the x value. X equals the x value. P is right here, so it's P prime is right there at 8, 4. Q is right here, so Q prime would have to be right here, which is at 2, 1. The y-intercept, well, we've already done that. And again, it is increasing as it goes uphill after 4, and it is decreasing as you go downhill before 4. Your homework is the next 2 pages. Please use the notes as I gave them to you, because especially on this page, that's all you're doing really in the homework. Have a good day.